Okay, thank you all. Appreciate this is the last session and you're probably pretty tired, so thanks very much for attending and giving me somebody to actually talk to, other than the sound guys. So yeah, I'm Claire Knight. I work at GitHub. I work on the API team. I've had many conversations over the last 2 days. I am, UK, and I live in the UK. We're a predominantly remote company. So that's how that gets to work, which is great because I get to work with amazing folks from all over the world, and also I get to come talk to you. So what I really want to talk to you all today about is using data to drive decisions, which might sound kind of obvious to some of you, especially if you're in management or data science or even performance folks. But we don't always do this with products in the right way, and I often say we're not necessarily doing the right thing with APIs. The other thing is, as I'm sure all of you that have public APIs know, is your users do really weird things with APIs, things you never ever wanted them to do. But that's collecting data on these edge cases, on unusual patterns and things like that is absolutely valuable for understanding what people are doing, not just from a security aspect. So, I mean, there are tools about them, and I'll get onto those and things, but we have a lot of things written internally in GitHub for our own use because it works better with the monolith that we have that's been well documented, and because we also have our own various places where we aggregate data. So what I'm going to do is talk to you about various things around why we would want to capture some stuff, why we would want to write it ourselves, and where we're doing that to maybe give you some insights if you wanted to apply that in your own organizations and own APIs. So you might be saying, why do I need to capture any more data? I've got a query coming in on the API. GraphQL is very expressive. I can know what people are doing and so forth. However, that is not as simple as it might seem from an operational point of view. There's a lot of things that we need to consider. And I'm going to cover each of them in turn, but there are things like we don't want to affect the performance in terms of returning response to the user. We have to be very careful in terms of data with the security and responsibility of using somebody's personal data. And then there's also the fact that some of the analysis we might want to do, because we care about aggregate things, needs multiple requests and requests from various places to be able to be actually meaningful to us. So on a per query basis, that's not going to give us as much information. So let's move on to this first one. It's just query performance. Now, I'm not sure if people are aware of the scale at which GitHub operates. I mean, we made a big thing about the number of millions of accounts we had last year, but we actually serve over 1 billion requests every day on our API. So we're talking some mega scale here. And we have to not only have the capacity to actually serve those in a reasonable time frame without, buying up the entire hardware stacks around the world, but also people are not prepared to wait undue amounts of time for a given request quite fairly. If you're making a request to get a few bits of data out of an API, it should return to you in milliseconds, and that's not a thing that integrators should be able to expect that kind of responsiveness. So if we were to start doing a lot of analysis during the query processing, we would have a hard time serving that many requests and responding in a timely manner to anybody that is making a query. So one thing we do is we look to offload the data so that we can do that kind of analysis later on. Which leads me very nicely into the next slide, which is the power of analysis. We are fortunate to have some really bright people at GitHub, the data science team and the machine learning team. In fact, we have a lot of bright people at GitHub, and they're all far better at math than I am. So I'm more than happy for them to do some of these aggregations and these clever queries and statistical significance of things, because I'd mess it up. But one thing that they have definitely used the data for is to look at patterns over time and to provide historical comparisons. That's also something that doesn't work great when you're when you're looking at data on a per query basis rather than aggregate in an aggregate form. And we also are starting to explore, or consider exploring, I should say, actually asking other questions, like looking at the data and saying, well, we have a bunch of stuff here. What could we use that to tell us? Could we feed that into some other analytics that we have over here? So that we've accidentally enabled the statisticians at GitHub to ask even more questions. So we may even end up capturing more data. So far, this has probably been in production about 8 months now. So we're getting a good bulk of data around that. And the final reason that we don't literally use the query and just dump that to a log somewhere or into wherever is that we want to ensure that we're compliant. We take security and privacy very seriously at GitHub, as should any company. Plenty don't know. We have to be GDPR compliant. We operate in Europe. We have European customers. We also care about PII, personally identifiable information, which is what I know that a lot of my US colleagues refer to this as. There's various things around this about we shouldn't be able to attribute, well, not if we want to keep it for a period of time, attribute certain things to individual users because it becomes their data, whereas if we store things anonymously or in aggregate, then it's just data about our service and how it's being used. I know there are grey areas and exceptions around, if you can log for a certain period of time, full details to ensure your service isn't being hacked, things like that. We do obviously secure our service that way, but those logs then have to be deleted completely, not archived. So we have to find ways of extracting the data out in other ways. So they're the 3 key areas. Now, it would be remiss of me to not mention that there are existing solutions. This fragment of JSON response here is from Apollo's tracing tool, which actually I got really excited when I found and then really upset when I realized I couldn't use it because of the setup we have. We're running on a Ruby on Rails monolith, and we therefore can't use a lot of the Apollo things. The other reason that we didn't want to particularly go exactly this route is that this is returning the resolvers. Now, we've got a public API. We don't own both sides of this. We're not client and server, we are just server. So if we were to return the resolvers and information of that level through to our clients, we're potentially exposing implementation details that could be used against us. And we sure as heck don't want that for the sake of all of your source code if you're using us. So I mean, if you are using anything in the Apollo ecosystem, I think this is a fantastic thing, and I definitely think you should go using that. So from a sort of a practical point of view here, I want to go over the things that we've found valuable and just give you a little bit of information on what those are. So I'll go across these from left to right. First thing is parsing problems. You may wonder why we care about that. If somebody sends us a malformed query, then they're just being a bit of a doofus. Except that we do care, because if we're getting repeated problems with certain aspects of our schema, then maybe our documentation needs to be improved. Maybe we need to put some examples out. Maybe the education team need to spin up something around that. Maybe our DevRel need to be involved. There's a bunch of things around that I think it helps us to help our customers. So that's the first one, the parsing problems. We also clearly care about resolvers that are unable to complete because returning a 500 to users kind of sucks a bit for your users when we could hopefully do better, even if that's to return an error of some sort, to give them some more information to either help themselves or come through to support. But 500ing doesn't really give anybody much other than oops, it broke. So we definitely try and provide a bit of information around that. Now again, because of the compliance side of things, we're not going to have the whole query with all of the parameters there, but we can store additional things around what objects are being accessed, because they're just objects in the schema. That's kind of public knowledge in that sense. And so being able to narrow things down helps us diagnose those problems as engineers. So that one is very much more for our engineering team internally. The domain objects being used actually helps both engineers and the public, although they might not see that. What this allowed us to do is, again, look at the areas that are popular, that get a lot of hits, that get a lot of traffic, that are hotspots. So we can, from an engineering perspective, look at optimizing those if they need to be optimized, or ensuring there's a good, clean, safe path, that edge cases are better ironed out, because, as I said, people will find the edge cases in your API, whether you want them to or not. So, again, capturing particularly the edge case information, we can fix implementations like that, or have a guess that there might be a problem before it happens, so we can see things off, which gives information to the engineering team, and ultimately they won't necessarily see it because we've fixed it already, but it helps our integrators for sure. The final other area that we found really valuable is around validation and security errors. We do need to kind of log something about people not being able to see things. It could be perfectly legitimate. If I'm authorized as me, and you have a repository that's owned by your organization and is private, then quite rightly I shouldn't be able to access that. So if I'm going to query for that, that is a perfectly fine validation or security message to give back. But there are other situations where it's not very clear in the resolving hierarchy how to solve that, because putting the security layers into the resolvers, and we have a complex permissions model at GitHub with the ACLs around all of the things, like you can have contributors and you can have moderators and all sorts of different kinds of permission roles. So we have to apply all of that, and unfortunately we're not perfect. Nobody's perfect. So we do get some edge cases around that, and by providing information about what group of things was being requested, we can learn a bit more about where we need to put better test cases in, more information, and things like that. So those are the sorts of things we care about. Now I'm going to kind of talk to you about where we capture this, and then I'm just going to briefly go over where we put the information that we've captured, because as already said, we're not going to be doing this in real time because of various reasons. So kind of like there's 4 areas of interest, there's also 4 main key areas where we capture the data. So one of the things we do is we capture information during parsing. This can be parsing errors, obviously, but also during parsing we can work out which objects are going to be accessed. So that kind of information we can put in an object and store somewhere. Excuse me. Within the resolvers is quite a rich source of information and context, because there will, for anything other than a very simple query, be a bunch of resolvers that are used. So we can sort of track where in the resolving hierarchy things are visible or not visible with the security things. We can track if they even are the right objects. Trying to think of some failure cases here, and my mind's gone blank right now, but we have had situations where things like that, particularly in development, that maybe not made it out onto production, that have gone super weird, and that extra logging, which is available to developers in development and just even to their console, is helpful, and that's something in the API team we would ask folks to use to help us help them as well. We also capture data when we're applying security, so that we know the ACL that's been applied, even if we abstract that away later from the individual token an authorization there. We certainly abstract that. We would never have a recreatable authorization token stored in this data. That would be so wrong. So we capture elements of what's being applied from a security perspective, which helps the engineering teams when they're like, why is this not returning this data to these people when they ask for it? But also we have some very smart folks doing application security, and they can kind of use that information, and they do when they have to investigate potential problems, they can go back through that too. The final place where we will capture information is before sending a response, and this is going to be a summary of what we send back, be that good or bad. That will be exceptions if they've occurred, error codes, or an overview of the data in a successful response. Again, I want to make it very clear that we're not literally saying, this is the chunk of data that we're going to send to this person. It's because that's private information once more. It's these type of objects and there's this scale of them. That's the kind of thing that we would choose to capture. So I've said we're capturing all these things. Where are we going to put it? Now, partly that's going to be down to you and how you have your system set up, your server code, and what other infrastructure you've got available to you. For us, we put it into 3 places because, you know, we're greedy and 1 isn't enough. So we have a data pipeline, a GitHub, which is built on and above and around Kafka. And we have some excellent middleware in our monolith already there that we can utilize. So we can pass in some objects of information. When I say objects, I don't mean GraphQL types. I mean things that we have there collected about a request. And it will be serialized in a way that can be stored relatively efficiently and that our data science team can then reconstruct into things that they can analyze later. We also make use of log files. Again, we're not going to be logging out the exact query or private information like that, but just things around the resolvers, the the parsing, things like that. Pretty obvious stuff there if you've been in computing for any length of time. And the final place where we like to put data is when into statistics capturing systems. Now, there's plenty of these out there, and again, you've got to pick something that works for you, but there's things like StatsD exporters, Prometheus-related things, or Datadog if you want commercial solutions, things like that. So we can get some idea in real time of some things. So we have graphs on our rate limiting and our abuse limiting things because they're useful if an incident might be happening, if we might be coming under attack in terms of volumetric things like that. That's not stuff that we necessarily want to analyze later, although we might in terms of an availability review, but we actually need to know that kind of stuff straight away. Although that's less of a, hey, we're using these lots of objects in a query, but it is something that we do. So I thought it would be beneficial to mention that. So there are all of the things that we do, and in the abstract how we've done it. So I apologize, I can't give you lines of code, but our code base is very unique to us, and I'm sure you all have your own dragons hidden in code. So I wanted to give you some, well, 3 key learnings that we got out of doing this. We as I said, this has been in production roughly 8 months now. So these things have kind of come up since that's happened, and we've been able to evaluate and see where we have genuinely got things moving forward. So the first thing is that we've been able to learn more about runtime errors. Again, this is making a better experience. We're not having so many 500s, which is better for our integrators. It's better for management that look at these graphs and get unhappy with development teams. It's better for the engineers because of that. Because it makes it a lot easier to identify what the problems could be and the errors that are being returned. We use the GraphQL Ruby gem, and I'm lucky enough to work with the maintainer of that. So one of the things that we did was improve the messaging around some of the errors when that's parsing, and we gave that back. I think I probably pushed that December last year to the gem, and then we were able to roll that out to other people as well as in GitHub, and then we use that in this data that we're exporting. The other thing that we do is to track expected errors. So a parsing error is a perfectly legitimate error if somebody's made a mistake. And yes, we'd like to know about that for the reasons of educating folks, but for management to look at a graph and say, whoa, you're getting a lot of, why are you not sending a 200 there? Why is this happening? They tend to worry sometimes when they shouldn't. And what this helps us do is to explain to them and to a wider audience that not all errors are bad errors. Some are user initiated. And it also helps for the SRE folks, and whenever we need to be in incident command and we're looking at various graphs and things, for me to now to be able to say, hey, look, no, this is within known ranges. This is good errors versus, whoa, what the heck's going on here? We need to have a look into that. So that's been really valuable to us too. And I guess the final one, especially when I've already said that we're having to deal with over 1 billion requests a day, is that having an idea of query size is really, really useful for my capacity planning. There's also the timeout concerns with individual requests too, but the capacity planning is very key to the business as well. So having that information more available is better for us. So for REST, it's kind of easy. I say that, REST people not hate on me for that, but what I mean is that an endpoint is a request, and every endpoint is a thing, and that's, given the standard CRUD REST design, that's what happens. Whereas with GraphQL, you'll just hit /GraphQL, and that request could be like a really simple thing, getting an object, or it could be requesting most of our database worth of objects, at least for public repositories, which is massive. So by having this information about the objects that we're accessing, we can at least say, we can like multiply things out and say, actually, this is realistically the capacity that the GraphQL requests are taking and what's going on there. And that helps us with, even forward planning a year in advance for hardware requests, because we run our own servers and things like that. So that's been super useful to us. My final thought before I let you all run away and relax your brains after 2 days of hard listening and learning, is that I think it's really key for public APIs, or ones of scale, or in our case both, that you have to consider things from the API owner's perspective. APIs really need to be thought of as a product, in my opinion, and integrators are important, and we definitely want to make things better for them, but you need internal insights to help yourself, you really do. And they're not, they're an often overlooked part of running an API, I think. Doing all of what we've done now, and over time, we maybe get to a point where we say, right, let's return safe and secure hints to users about what they are doing and why it would be better that they didn't do that, or they didn't do it that way. But what we really need is to gather even more data than we have, and more long-term analysis to do that. And so that's something that we would be looking to do in the future. But we're getting real-world data now, and it's been super helpful to us. So if you've got situations where you don't own the client and the server, I'd really encourage you to log as much as you can in a safe and secure way, because it's really helpful to you. And yeah, if you have any questions or comments, you can find me in all of those places. I like to be consistent with my name. It stops me getting confused. So, and yeah, I'd really like to thank you for your time and for listening to me.